We are in the search of science at Indian Mills Memorial School. You! Yes, you! You there! What are you doing?
We are playing field hockey. Okay, field hockey.
Would you like to demonstrate some scientific experiments for the sake of science?
Yes, for the sake of cake.
Alright, sweet.
In the first segment, we're going to talk about speed and velocity in field hockey. Speed is how fast an object travels. It is also equivalent to distance over time. Velocity is the exact same thing as speed, except that velocity involves the direction the object is traveling in. Right now, the ball has no speed and is not traveling in any direction, therefore it does not have velocity. Done. 20 kilometers per hour north velocity. Yeah! That's what I thought!
Acceleration is the rate at which velocity changes. In science, it refers to increasing speed, decreasing speed, or changes in direction. Here's some acceleration now. Oh, it has just changed direction.
At your face!
This is some great acceleration. Wow.
Ow.
You serious? The force that two surfaces exert on each other when they rub against each other is also known as friction. There are 4 types of friction: static friction, sliding friction, rolling friction, and fluid friction. The strength of the force of friction depends on 2 factors: how hard the surfaces push together, and the types of surfaces that are involved.
Here's some friction now. As you can see, there is rolling friction going on. How about you just hit it that way? There is rolling friction. The ball is slowing down because of this. It has now come to a stop.
It's like gravity is a force
No!
that
No!
pulls-
Get out! Move! Now!
I want to.
Go!
No.
Yes, go!
No. Just study.
This is not your job! Get up!
Ah!
God!
Ah!
Gravity is the force that pulls objects towards each other. The force of gravity acts between all objects. If mass increases, the force of gravity increases. If distance increases, the force of gravity decreases.
Now, we're about to watch gravity in action. As the ball goes up into the air, gravity acts on it and pushes the ball down at a constant rate of 9.8 meters per second squared. There it is again. Newton's first law of motion states that an object at rest will remain at rest, and an object moving at a constant velocity will continue to move at that constant velocity, unless it is acted upon by an unbalanced force. Inertia is the tendency of an object to resist a change in motion. Newton's first law of motion is also called the law of inertia. Some objects have more inertia than other objects. The greater the mass of an object is, the greater its inertia, and the greater force required to change its motion.
Newton's first law is be putting to the test right now. The ball keeps moving until the goal stops carrying an unbalanced force.
Sweet.
Newton's second law, or second law of motion, states that acceleration depends on an object's mass on the net force acting on the object. Therefore, acceleration equals net force over mass. Acceleration is measured in meters per second, and mass is measured in kilograms Then, force is measured in kilograms times meters per second.
Newton's third law of motion states that if one object exerts a force on another object, then the second object exerts a force of equal strength in the opposite direction on the first object. Another way to state Newton's third law is that for every action, there is an equal but opposite reaction. We're going to demonstrate Newton's third law, which states about equal and opposite reaction.
I thought you should only use the flat side.
Okay.
So today we're going to be hearing research of science. You over there. Yes, you. What are you doing? Are you filming? You're not supposed to be filming.
You bet I am.
Today,
Yeah, okay. All I said was today, Colin.
today,
Really?
today, we are in. No, now you're laughing.
Done. 20 kilometers per hour north. No, I'm done. 20 kilometers per hour north. Again!
Go.
Some objects have more inertia than inertia.
Oh god!